AS Quantum Physics video number 3 is about spectra. I've done another video on spectra for year 2, so it's very similar to this one. Where does light come from? If we think about, we know what light is now, it's these packets of energy called photons. Where does light come from? Here's lots and lots of different examples of things which emit light. Do they have anything in common? Well, light comes from excited atoms. Imagine an atom which is snoozing. We say it's in its ground state. Now, we can excite an atom if it absorbs energy. There's lots of ways that we can excite atoms. We can bash them into each other. We can bash them with electrons. We can use electricity. Atoms can become excited, and when they get excited, they gain energy. And then an excited atom loses this energy by giving off a photon, and we say it falls to a lower energy level, and the lowest energy state is called the ground state. We can represent what's going on with an energy level diagram. What's actually happening inside the atom is that an electron is jumping to a higher energy level. We say that the electron is becoming excited. It jumps up to a higher energy level, and then sometime later the electron falls back down to a lower energy level, possibly the ground state, and a photon is emitted. Now, this is the emission spectrum of hydrogen. If we excite hydrogen gas, then it gives off these colors. This shows us the visible light emitted by hydrogen atoms. And notice that we get definite wavelengths of light. It's almost as though each element has its own barcode, and this is the barcode for hydrogen. Why do we get definite colors emitted? And the answer is because the energy levels, it has definite energy levels. And there's lots of different energy levels. The lowest is the ground state. We call that n equals 1. Then there's more, n equals 2, n equals 3, n equals 4, all the way up to n equals infinity. And if an electron can get up to there, then it can escape. Excitation involves jumping up to a higher energy level. Emission involves falling to a lower energy level. We can give values to these energy levels in electron volts. The ionization of hydrogen is 13.6 electron volts, so my ground state is minus 13.6 electron volts. Then to figure out the energy of a photon, if we know what energy levels it transitions, then we can work out from the difference between the two energy levels. For example, if an electron fell from n equals 4 to n equals 2, then looking at the numbers, the energy of the photon would be 2.55 electron volts. And then using this equation, we can work out the wavelength, and we get 488 nanometers, which is the green line in the spectrum. Okay, here's a couple of questions for you to have a go at, and I'll show you the answer in 3, 2, 1.